Hello, this movie is on Unit 9, Transformations, Learning Target 6, Dilations. A dilation is when we take a pre-image in this case being this guy, and we apply a dilation to it about a point. So what that means is from the point, we are going to travel through the pre-image point and go the same distance as the dilation. So the dilation has a scale factor to it, meaning this might be twice as much as this one as far as side lengths. When we dealt with similar figures, we had a scale factor, and that scale factor is the same in a dilation. So just like we did in Unit 7 with similar figures, we are going to find that the sides are proportional. And the scale factor we get with the sides is the scale factor we're using in a dilation, because a dilation is going to enlarge or reduce the figure. If your dilation is a scale factor of 1, that means that it's a congruent figure. You have the same lengths for each side. So not only that, we have a point of dilation. And a point of dilation is where we're dilating from. From this point, if I extend through my pre-image, and that is a length of x, I will go twice that length, because my scale factor is 2, to get what the image would be. So if this is A, that would be A prime. If I travel here, and that's B, then this would be B prime. So there's B prime if that one's B. And then my point of dilation, I travel this distance, I go twice that distance to get to here. This would be C prime if this is C. So there's two things going on. You've got the point of dilation, which in this case is Z, and the scale factor is 2. So those are the two things we'll be looking at. The other thing I want to highlight is notice how from the point of dilation it acts like a sun ray, and it's going through the pre-image to the image point, through the pre-image to the image point, through the pre-image to the image point. That happens all the time. Look at this. We've got the sun ray happening through the pre-image to the image point. Same thing is happening with the others. So let's get these lengths. AX. X being the point of dilation here. A to X, I'm getting this distance. It's a quick Pythagorean theorem. So create a right triangle. Get your Pythagorean theorem where AX is the hypotenuse. This is a length of 1. 1, 2, 3, 4. That's a length of 4. So you've got 1 squared plus 4 squared equals AX squared. So you get 1 plus 16. This is root 17, which is about 4.123. A prime X is now this distance up here to X. So I'm going to build a right triangle there. And this is 4, 5, 6, 7, 8. And this is 2. So it's 2 squared plus 8 squared equals A prime X squared, which is going to be 4 plus 16, or 64, sorry. We get square root of 68, which is approximately 8.24. Now, what are you noticing about 4.123 and 8.24? It appears to be twice as much, which makes sense because we have a scale factor of 2. That means that the distance from X to A, twice that distance is X to A prime. The same would be true for X to C prime, X to B prime. Now, let's look at just a side length of the figure. So if we were to just look at our side lengths, which we're basically going to prove that it's proportional. AC is a length of 1, 2, 3. A prime, C prime is 1, 2, 3, 4, 5, 6. And you can see that it's twice as much. So two things are happening with the dilation. It's the pre-image. If I take the distance from the pre-image to the point of dilation, and I go twice as far traveling in a sun ray path, I will get the image point. And the similar figures have sides that are proportional in that same dilation scale factor. So those are the two things you need to know. Let's look here. Let's dilate about the origin by scale factor of 2. So we're going to take our point of dilation from X. It's acting like a sun. So we're going to do our sun rays. From X, and this doesn't matter how you travel. We're not trying to do slope. We're not trying to find lengths right now. But if I go from X to the right, 1, 2, 3, 1, 2, 3. I went to the right 3, down 3. Got to do it again. 1, 2, 3. 1, 2, 3. Scale factor is 2, so I'm going twice the distance, which puts B prime out here. C prime, if I go 1, 2, 3, 1, 2, 3, left 3, down 3. I got to do that again. 1, 2, 3, 1, 2, 3, left 3, down 3. Again, be consistent. C prime is going to be down there. Now to get to A, I go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So A prime is here. And you can see I've gone, if that's 1 unit, I've gone twice that length to get to A prime. Then we connect our primes. And this gives us the image of a scale factor of 2 with X being the point of dilation. Here's our original. Oops. Didn't think it would do that. So take the original triangle, dilate about point X, scale factor of 2, we get those primes. Okay. Dilate about the point -9, 8 by a scale factor of 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. There is the point of dilation, X. We're going to call that X. Pause the movie, press play when you are finished. Okay, to dilate about this point, we're going to travel 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 2, 3, 4, 5, 1, 2, 3, 4, 5. To get A prime, we go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. C prime, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. B prime. And then you might start to think, wow, this feels very similar to the one we just did. And the answer to that is yes, it is, because it doesn't matter what that point of dilation is. It still acts the same way. It acts like a sun. It becomes a sun ray. It doesn't matter if it's the origin or -9, 8. The same properties are holding true. From that point of dilation, you go through the image to get pre-image to get your image. Go through the image, pre-image to get your image. Go through the pre-image to get your image. And you go by twice the distance, scale factor of 2. So that's the point of that one. Let's look here. Where is the point of dilation? What is the scale factor? Well, in this case, we're just going to be working backwards. So if we connect A to A prime with a nice little line, and we do B to B prime with a nice line, and extend it, C to C prime with a nice old line, then you can see where these lines all intersect. And they all intersect at this point, 1, 2, 3, -1. That is the point of dilation. Because the point of dilation always goes through the pre-image to get to the image. So it's that connector. It's acting like a sun ray. What is the scale factor? Well, 1, 2, 1, 2, 3. That's a unit of 1, basically. And if I do that again, 1, 2, 1, 2, 3, there's another one. So I went twice the distance. So it's a scale factor of 2. The same thing is true here. 1, 2, 1, 2, 3, 4, 5. Distance of 5. 1, 2, 3, 4, 5. 5 here. So 5 to 10, 10 divided by 5 is 2. It's another way of looking at it. Any way you look at it, scale factor of 2. Now, looking at this, can we write a rule to describe each of these? Let's look. We've got a to a prime. So what we're going to be considering is, what did I do to negative 5 to get negative 3.75? What did I do to 4 to get 3? What did I do to negative 2 to get negative 1.5? So that's what we're asking ourselves. So grab a calculator and let's investigate this. Negative 3.75 divided by negative 5 gives you 0.75. Oh, let me use green. Negative 3.75 divided by negative 5 gives you 0.75. 3 divided by 4 is 0.75. Then over here, negative 1.5 divided by negative 2 is 0.75. So all of this is telling us that the dilation has a scale factor of 0.75 or 3/4. And that's how you get it. You just divide your primes by your originals. The line 2y minus 8x equals 11 is dilated by a scale factor of 5 about the origin. What is the slope and the y-intercept of the dilated line? So if we just did a little makeshift graph of this, and I took 2y minus 8x equals 11, put this guy in slope-intercept form. Oops. I would get y equals 4x plus 11 over 2. That tells me it's going to look about like this. Now, if I dilate about the origin, and I think of doing that to every point on this line, what essentially is happening is that it's just moved out, but the two lines will be parallel. So what we end up with are, what is the slope? The slope is the same. And the y-intercept is going to be this y-intercept, 11 over 2, times 5, because that is our scale factor. So that's a little bit of an extension, more for honors than anyone. What would be the length of B prime C prime if the triangle ABC was dilated by a scale factor of 6? So you can see graphically that's not going to happen here, because I can't do a triangle 6 times this big on this graph. So what I'm going to do first is just get this length of BC, because if I get BC's length, then I can multiply by 6 to get what B prime C prime would be. So BC, I'm going to draw a right triangle, use some Pythagorean theorem. I get 1, 2, 3, 4, 5, 6. 1, 2, 3, this is 8. So I get 6 squared plus 8 squared equals BC squared. So that gives me 100 equals BC squared. Square root of 100, that's 10. BC is a length of 10. This is actually a 3, 4, 5 Pythagorean triple. You can see that multiplied by 2 here. So what we've got, BC being 10, a scale factor of 6 says 6 times 10 will give us 60. So B prime C prime will be 60 units long. And you just apply your scale factor. So in this case, we're actually going to skip this one on the movie, and that's all for the movie on dilations. Thanks for watching.